Okay, so this video is on Markov models in artificial intelligence. So let's say you have three universities, Harvard, Dartmouth, and Yale. Now assume that 80% of the sons of Harvard men went to Harvard and the rest went to Yale, and 40% of the sons of Yale men went to Yale, and the rest split evenly between Harvard and Dartmouth. Also, the Dartmouth men, 70% went to Dartmouth, 20% went to Harvard, and 10% went to Yale. So you're just gonna use all this data and make a Markov model from them. So how do you do that? So first of all, you're going to show the transition probability matrix. So the way you're gonna do that is that there are three variables here. So the three universities, Harvard, Dartmouth, and Yale. So you're gonna make a 3 by 3 matrix first. So let me just show you here. So Harvard, Dartmouth, and Yale, and on this side Harvard, Dartmouth, and Yale, and you're just gonna make a 3 by 3 matrix here. So first, 80% of the sons of Harvard men went to Harvard. So this side is the current generation and this side is the next generation. So 80% of the sons, so basically the father, and 80% of the sons is 80% of the men. So the previous generation of Harvard men went to Harvard. So Harvard given Harvard 0.8, and the rest went to Yale. So Yale given Harvard is 0.2. So there is no one in Dartmouth. So this one's gonna be 0. Now 40% of the sons of Yale men went to Yale. So Yale given Yale will be 0.4, and the rest split evenly between Harvard and Dartmouth. So the rest is basically 1 minus 0.4, so 100% minus 40%, that's 60%. So half of 60 is 0.3, 30%, which is 0.3. So Harvard given Yale is 0.3, and the other half is 0.3, Dartmouth given Yale. Now, of the sons of Dartmouth men, 70% went to Dartmouth. So Dartmouth given Dartmouth is 0.7. Okay, so 20% went to Harvard. So basically, this one's the son. So Harvard given Dartmouth is 0.2. And 10% went to Yale. So Yale given Dartmouth is 0.1. Okay, so next, calculate the probability that a grandson of a man from Yale went to Harvard. So now you're going to find that the grandson of the grandfather went to Harvard, and the grandfather's from Yale. Okay, so basically, if I take three variables here, x1, x2, and x3, x3 will be the grandson, x2 will be the father, and x1 will be the grandfather. So here it's grandson of a man from Yale. So the grandson of a man is basically, the man is from Yale, so the grandfather is from Yale. The grandson is going to Harvard, so x3 equals Harvard, and x2 is not given, so this can be either Harvard, Dartmouth, or Yale. So now you're just gonna make a probability out of it. So probability of x3 equals Harvard given that x1 equals Yale. So since x2 isn't given, you're gonna have to calculate that. So basically, x3 equals Harvard given x2 equals Harvard. I'm just gonna take this one first, then this one, then this one. So x2 equals Harvard times probability of x2 equals Harvard given x1 equals Yale times the probability of x1 equals Yale. So this is the basic formula of Markov model. So Markov model is like you got like x2 here, so x2 given x1 first. So if they're like x2 and x1 variables, so x2 given x1 multiplied by x1, probability of x1. This one's probability as well. So if they were like x3, so x3 given x2, then probability of x2 given x1, then probability of x1. Okay, so really simple way to do that. Okay, so back to the math. So this is for the x2 equals Harvard. Now you're gonna have to like find x2 equals Dale and x2 equals Yale, Dartmouth and Yale. Okay, so probability of x3 equals Harvard given x2 equals Dartmouth times probability of x2 equals Dartmouth given x1 equals Yale times probability of x1 equals Yale, or probability of x3 equals Harvard given x2 equals Yale times probability of x2 equals Yale given x1 equals Yale times probability of x1 equals Yale. Okay, so you're just gonna like put the values in now. So probability of Harvard given Harvard, so you're gonna go back to the matrix here and check it out. So Harvard given Harvard is 0.8 times probability of x2 equals Harvard given x1 equals Yale. So Harvard given Yale. So Harvard given Yale is 0.3 times probability of x1 equals y, which is basically 1 plus, or basically, so like x3 equals Harvard given Dartmouth. So Harvard given Dartmouth is 0.2 times probability of x equals Dartmouth given x1 equals Yale. So Dartmouth given Yale is 0.3, or multiplied by 1, or probability of x3 equals Harvard given x equals Yale. So Harvard given Yale is 0.3 times y given y, which is y given y is 0.4 times 1. So this should add up to 0.42. Okay, next, find the stationary probability distribution for this Markov model. So now you are going to have to make 3 equations. So like for equation 1, you're going to take variables like 0.8, you're gonna take like the vertical values as variables. So let me just show you. So like there are 3 variables, so like take 3 values or 3 variables. So 0.8 A, I'm just gonna like take the Harvard for A, Dartmouth for B, and Yale for C. So 0.8 A plus 0.2 B from here, and 0.3, so 0.3 C equals A. So like this column equals Harvard's, so total probability is going to be like 1, so I'm just going to take 1 here. Now 1 minus 0.8 is 0.2, and if you put the B on this side and 0.3 C on this side as well, so that's negative 0.2 B and negative 0.23 C. Okay, so this is equation number 1. Equation number 2 is 0A plus 0.7 B plus 0.3 C equals Dartmouth, so basically equals B. So 0A plus 0.7 B plus 0.3 C equals B. So this is 0 minus 0.3 B. I'm going to take it on this side, and plus 0.3 C equals 0. This is the second equation. And for the third equation, you're going to take this column. So 0.2A plus 0.1 B plus 0.4 C. So 0.2A plus 0.1 B. plus 0.4c equals, okay, so instead of taking this column, you're just gonna like take all the variables. So a plus b plus c equals 1. So like all the variables equals 1 probability. Okay, so this is gonna be the third equation. Now you just like simply put the values in the calculator. These are the answers. So a equals 5 by 21, b equals 8 by 21, and c equals 8 by 21. So this is basically how you do it.